Hello, everybody. So today finishes up week 4 as far as lectures go, halfway through. I guess technically week 4 doesn't end until the homework's due next Monday, but moving right along. I got all of the project proposals created, at least the ones I received last night. So some really good games. Um, I'm gonna have to come back. I've never decided that I get a game didn't sound big enough for a class project. But I never have to go back this time and tell anybody that that's way too big. Because that's what usually happens. That's usually the only feedback. They also have like really great, good projects for the class. Um, all of them that had been turned in by last night. Uh, went through those. So yeah. It's gonna be time consuming when we have other work, so make sure you're doing a little bit on that final project every week, because that is what's in the class. Okay, so today got some more animation stuff. There was a little bit with that skeletal animation from Monday that we didn't get through. We created multiple animations, but we need to look at how to switch between those in our code. As well as turn the character around. So 2D games, we don't want to draw every single animation once, right? We don't want to draw a walking left animation and then come back and draw another walking right animation. We just turn that around. It's really, really easy. It's just a scale.
I mean, things keeps you.
Oh yeah, yeah, yeah.
Look at this.
Yeah, so it often is just one click like that, but yeah, we can do it really easily in the code, which then also only cuts the number of images we have to load in and makes fewer images we have to load in. So we'll look at an animation tree, and then a small segment of script, the part what we need to do to switch between those animations, and yeah, then turn it around so that it faces the other direction. Then we're going to look at some schematic stuff. You remember some of the stuff setting up the bone seemed a bit tedious. So today is a little bit more of that. Like, well, obviously it's more of the same thing, but more tedious. We have to be very, very careful. But let me download my credit files and show you what we'll be the animation stuff we'll be building to. So that way, when it's when we're there making minute adjustments to our bones and the remote transforms and the graphics and making little minute adjustments to get everything in the right spot. Oh yeah, pictures of cocktails. The website this year is a bunch of cocktail recipes with ads on it. Maybe that'll make some money. But I keep gotta add to the page. So more pictures from last night. I forgot those were on there. There it goes. Okay. Yeah, that was the teaching SF 153, the first 8 weeks. The example site I used that I set up over Christmas break was a bunch of cocktail recipes and showed them how to put ads on it. That's gotten earlier and earlier. When teach SF 153, I show them how to put ads on their websites in like week 1 now. Still hoping that somebody's going to have that in there. So, so I quickly drew this shape. Like last 20 minutes, I was in my office or so last night, and I went home, and it took about 15 minutes to get the skeleton in there, and then about another 10 minutes or so to make little adjustments. So not super long. Wait, is this not the finished version? Where's my targets? Okay, actually, sorry, I don't have the finished version on here. I could have swore I uploaded that after I finished it. Oh, wait, I know what it is. Um, I didn't open the one I just downloaded, sorry. My brain went elsewhere for a second. That was what I did in 20 minutes before I left the office last night. And then I went home and put it on the other computer. All right. This is our, inverse kinematics is a, sounds really fancy, right? Got those big words going on. You have to kind of think about what they're meaning, what they might mean. And then when we talk about it, like, if you look up tutorials and documentation on it, there's just all sorts of, more of that, just lots and lots of really complicated sounding terminology. But really what it is like marionette puppets. We'll have like 4 strings, took the head off, so just our limbs. We have just 4 strings and use that to completely control the puppet and get very realistic movements. Just kind of like the way we move. When you walk, if you pay attention, the only thing you think about is your ankle. And the rest of your body just comes along with your ankle. Or when we reach for something, we just think about where our fingers need to be. And then the rest of our body just follows the fingers. So it's kind of like that. You'll see down here, there are 4 things, call them targets usually. So like the right arm target, if I grab that, it's like right here in the hand, and we get this nice, smooth, much more natural movement between that, or the left. You can see that it's just like that one connection point. You can do much nicer kicking animations than what we drew for our example. I think. Did we do a kicking animation in class, or did I do that in a video? I might have done that in a recent video. We see how we can get all of our body positions with just by dragging that around. The rotation is handled internally. So we'll look at that, but we have set all the stuff up for that. I'll say that. Those. Right, so start with what we kind of ran out of time for the other day. As we could have made it fit, but a couple of people had already asked to meet with the groups. Do you want to meet with the groups today in breakout rooms? Nobody's sent word this time, but I kind of expected. Okay, I see at least one head nod. The 7th at 2 o'clock, I think that's the right one. So we'll make sure there's plenty of time, yeah. Zoom breakout rooms are kind of nice. They leave messages in Discord, we can go back and forth, but it's not the same as actually sitting there talking in live time, or if anybody turns the camera on, seeing facial expressions and hand gestures and all that other parts of human communication that don't make it into text messages and chat rooms, right? There's a lot of communication missing. All right, so like the animation player. So we set up these 2 animations. There's the reset one, so we have an idle animation. Set it to apparently spacebar isn't play on this one. With the dragon, they get a little impatient. Oh, we can hide the skeleton. Those graphics are only a reference. We don't really need, oops, not the dragon. Hide the skeleton. Right, we could do a lot more if we would have put 2 joints down the leg so that it could bend. We'll want to do that on today's thing. And we just set up the key frames that we want it to be in a certain position in a certain frame. And the computer fills in the rest. Interpolates the rest would be the actual term. We switch to the walk animation. Just a very simple walk because we were running low on time, but as you put yours together this week, you'll probably want to spend a little bit more time and get things looking nice, because when something's walking, it's the rest of its body is going to bob around a little. Something with 4 legs and a tail is going to be using that tail to counterbalance as it walks. So things like that we kind of ran out of time for.
So it's pretty universal way to animate stuff other than spreadsheets.
Yeah, and this one is a lot more common because this one's programmable, right? Over in our scripts, because all we did was rotate the bones and stuff. So let me just do so when we're over in our script, we just grab a reference to that bone, and then dot rotation plus equals degree to radians. So we have to make that conversion like 34 degrees, and then that's exactly what we did with our mouse. So this is the programmable animations, which
And so what they're doing, use that to make the NPCs and stuff actually react players do it.
yes. So we had a lot more control.
It's not like in the original Super Mario Bros. Where most of the mobs just wander back and forth, walk shit, like fall off the leg.
Yes. The place I go to play classic games when I feeling nostalgic, it's retrogames.cc. They put all of the other alternatives. I don't know if you've heard the story, but when they first made Super Mario Brothers, they made a bunch of different characters before they settled on Mario and Luigi. And all of last weekend, when I was sitting there for office hours, I opened that up, and all of the other characters other than the Mario and Luigi were there. Everything else in the world was exactly the same, but it was kind of interesting to play with different characters. Okay, sorry, I'm easily distracted. Okay, so we have our animations. We just need a way to switch between them. So if we go up to the root node and add in an animation animation tree. I said it wrong the other day too. Animation player is where we store all of our animations, and then an animation tree is where we connect them so that we can get back and forth between them. Choose which one plays. So down here in the bottom, go to the animation tree tab. I don't know why it doesn't automatically open. We see there's a couple things we have to set up. So it doesn't have a graph set. We need to set over here where it says tree root. There's a couple options. So we can set it up as basically like a normal hierarchy sort of tree. Blend tree, blend space, those give us different controls for obviously blending animation and other, or mixing and matching. So instead of having entire animations built, you'd have like different segments of an animation. Those are popular in like fighting games, because then you can build up lots of different combos without having to do every single combo animation separately. You have like a punching one that you use that animation, blend that animation with different punching and kicking animations in the fighting game. What we want is the state machine. So state machines are nice, easy ones to work with. We're either going to be in a walking state or an idle state for what we have here. But you have your different animations, and you're going to be in one state or another. And we have this same. This one is also identical in all of our major game engines. So it's a state tree is sort of a standard setup and all. Before I forget, sorry. So you see, we start with the two states that everything's gonna have. It's gonna have a start and an end state. And what do we do afterwards? So these three buttons here, the middle one adds new nodes to this. So when you click, looks like add animations grayed out. Over here in the inspector, notice it needs to know what animation player it connects to. So just assign that to the animation player we created, which if you click on that, it should, yeah, there's only one to choose from in this case. Or if you have several, you can drag and drop. We'll connect to that animation player we just created. So now when we click, we get to the choice of which one of our animations to add, which obviously we probably want both of them. And then the third button is where we set up the transitions. Yeah, these are standard in all of our things. There's not a whole lot of buttons to go with. So as soon as it starts, obviously we're going to be in the start state, which doesn't really have anything to do with our animation. So where do we go from there? And you just click and drag. So when it starts, it's immediately going to jump over to the idle animation. Then we want to create another transition from idle down to walk when we start walking, and another one from walk back to idle. Right now, it's kind of stuck and confused. You see things flashing chaotically, can't figure out what to do. We need to set up conditions. So if you go back to the arrow, the select tool, select one of the transitions. And then here, we expand everything. How do we switch between animations? Intermediate just kind of blends them. In most of our other game engines, we have better control over that, like how it blends. And this one, they blend together over the last few frames. Sync means it's the new animation is going to immediately start playing, but the current animation will immediately start playing no matter what frame it's on, or at the end, which obviously it's going to get to the last frame of the animation and then bring in the new one. Intermediate usually works because we're talking about a frame or two and just let it blend. And then under advanced, we can disable or enable it. But the big one we want is the condition. So we want to set up some sort of value that we can refer to know when to do that. So I'll go with like is walking. So when is walking that'll be a boolean in our code. So when that's true, we go to the walking state. And for the other one, we can just kind of set up a variable is idle. You can set it up with the same variable and say like is walking and then add the negation. So when is walking is false, it goes to idle, and is walking is true. I stopped doing that a few years ago because it just makes the code look a little bit easier to follow if every state has a uniquely named boolean. And they are booleans, so that it's a one-bit variable in our code. It doesn't we have to have a whole lot of them before it's going to start slowing down RAM. We can deal with lots of booleans. So then we'll just need to transition between those in our code. Which we can go ahead and set up the script here. I'll go to the top level and attach a script to it. That may work. The power button on this didn't seem to come up. Okay, I heard it beep that time. That might be easier for y'all to see them here. You zoom in so that's nice and big in everybody's screen. Then we have our control that we always need. the ready function, which does the setup. But, well, we need to refer to that animation tree, right? That's what has our booleans. So, I'm gonna grab and drag that in. It was, for this annotation of on ready, took the place of everything we used to put in the initialization function, so. That doesn't get used as much as it used to. But the standard for setting up a game, like, right, we, get all our variables ready, then we have the initialization function that runs one time. Get everything set up, and I'll go with physics process. And then our function or functions that are gonna run every single frame of the game. So what do we need to do here? I guess we can just check to see. I'm gonna add some white space. Wait, that was just because I don't like typing at the bottom of a screen, and I can't scroll down unless there's extra lines down below. So here's what we can do. We can just check and see if one of our left or right buttons is pressed. So is action pressed? UI left or input is action pressed UI right. And that should be what moves our character from idle to walking. If we push either left or right, then we need to set the walking animation to true. So I'm going to make this a little bit shorter so it's easier to type. Instead of having the whole animation tree spelled out there, I'll just abbreviate it sort of. And to get to that, in our code, it's handled like a dictionary. So all of the states that we put in that animation tree are labeled as dictionary with what they're set up. So with that selected, under parameters and conditions, here's the two variables we want. Is idle or is walking. So if we progress left or right, then that means is idle is going to be false. And we can just drag it in. That's probably the easiest way. So that's why when we just drag and don't hook control or anything, everything always comes in as a script, because a whole lot of the objects are set up as dictionaries. And if they're not dictionaries, they're set up to have tags so that we can just refer to things by strings. So you can see the words there, parameters / condition, and then the variable we want. That's going to be false if we're walking. And then our other one that is walking animation. And notice the formatting. If you haven't seen this before, right? I wrote that in all lowercase with underscores. So in snake case, all lowercase letters with an underscore between them, and it reformatted it to look nice in the inspector panel. If we're walking, then that's going to be true. Then copy those. And I think in this situation, we would have an else, right? Because we're either pushing left or right to move the dragon, or we're not, or we're standing idle. So I'll just paste those in and swap the true and false. If we're not pushing one of those keys, it should go back to the idle animation. Get that running in the check. Which UI left and UI right is the arrows. It'd be nice if it set to WASD by default. So as soon as it starts, it transitions from the start state to the idle. And then when I push left, we start walking. let go of left and goes back to the idle. Push right, it goes to walking the wrong way, but it looks like those animations are behaving correctly. That makes sense? How to set those up? Switch between them. Yeah, so animation tree, every animation we create is just a different state. And they're all Boolean values and references, so in total, that's gonna be 9 bits for each line. So after years of making games, I stopped trying to abbreviate that because 9 bits isn't much. And just go ahead and it will be helpful to go ahead and do a line for every single animation. If you have thousands, then 9 bits might start to matter. But for most game characters, you're not going to have enough animations where 9 bits is really going to make a difference in the rank. So let's look at turning around. The way I usually do it is I'll just create a variable. Almost always call it left. Be a Boolean. And when we start, our dragon is facing to the left. So it's going to start as true. As far as left and right, and I don't want to call the variable right. So if left is true, then the dragon's going to face to the left, and left is false, it'll face to the right. And we would just change that with the key press input.is action pressed, or really just pressed. Like if we push left once, UI left, dragon turn and face left. As soon as we hit that, whether we hold it down or not, and then it's going to stay there until we hit the right arrow once. So left equal true. Otherwise, and elif this time because there's a whole lot of other things that can happen than just pushing the left button. So I just want this one specific condition. Is action just press UI right? So when we hit right once, set left to false. And then we can, just check that. So if left is true, to turn it around, I think we looked at this the other day. We choose our the top level dragon object. We just set our scale to -1. And that flips it around. It flips it around the origin. So the other day, wrote down where the center of the character was. At the center of the thing, which should probably be at the origin. That would make a lot more sense. Makes sense to put it right there at the origin. But it was 612 pixels, so now it's going to be 612 pixels back over to that line and flip across. And then another 612 pixels to put it back in the same spot. So that's 12, 24. There we go. So if we make those two changes, it just flips around and it looks like it just turned around to go the other direction. If you put the position, like center it right there at the origin, then it would just flip around in the same spot. But I put it off in just a random spot as I was dragging things in the other day. So you might have to make a couple adjustments like that, but that's all it takes to turn a character around. So I'll reset those. So if we're facing to the left, we're going to have the regular scale because that's our default size. So since this is attached to the dragon, it's automatic. We just say scale, and that's automatically going to access the transform for the dragon. We don't have to put self.scale or anything. Scale is a vector 2, and by default, it's 100% in both directions. just the 100% scale and the X and the Y. And then our position, since we will be changing in the other one, also a vector 2 object, we want that at 0, 0. Otherwise, so if left is false, means we should be facing the other way. Set our scale to -1 in the X, and then regular in the Y in this case, but obviously if you wanted to flip, if your game was set up so that you needed to flip across the Y value instead of the X, you can change that. And then our position in a vector 2, and then that number we just found, 1224, or that I wrote down the other day. So it's always good to have a piece of paper to jot little things down, numbers down you might need. And then the Y is not changing at all. How's that read? Oh, I forgot the 2 on the vector. It's 2-dimensional vector. That makes sense. There's something in the chat, but I think it's what was there earlier. Oh yes, thank you. Somebody wrote in that number from the other day. So now it should kind of behave more like we would expect a character to. Walking to the left, let go of it, it goes to idle it. We hit right, it turns around, and when we let go of the right key, it's still facing that direction until we go in and hit the button at least once to turn it around. And we're under tight time constraints, so not the best walking or idle animation, but hopefully you see the key parts there so that you can do something much, much better than that example whenever you get to your homework and there's more time to do that. Hopefully you're having a little bit of fun with it as well. There we go. That way it's bigger on the board up here. Okay, so that is the direct control one. That it can be kind of nice because we can think about the shape we want it to go in and all, but well, we already talked about today. But there's other ways where we, in living things like our own bodies, our bones are all connected, so we don't need to worry about every single bone, right? In order to put my hand right here, every bone has to be in a certain position. And it might be a little time consuming to go through and to set the position for every single one of those bones. So that's where inverse kinematics comes in. So I'm gonna jump over to Inkscape to draw a picture for it. Not a good picture, but a picture. So let's do a simple human shaped character. I'm gonna click. There it goes. But the thing is, we want the parts, like all the parts we'll need. So something we just talked about the other day, we need to have multiple parts for our arms and legs. We'll talk about it when we get there. We're going to use what's called 2-bone inverse kinematics. So we need to have at least 3 parts. We need to have, like, our arm needs to at least have an upper arm, lower arm, and the hand separate. And then we'll move the hand, and then the inverse kinematics applies to the 2 bones leading up to it. I'm doing the arms and legs, and then I'll leave the head for you to mess around with. And remember, I'll leave one body part for y'all to figure out, and just remember Control Z is undo, and try not to yank out all your hair as you're figuring out the little intricacies to it. It can be a little frustrating at times figuring out some of the finer details, When we get to 3D, inverse kinematics is, if we get off of our plane, you always want to treat your movements like you're in 3D, right? Our legs just go forward or back. They're not swinging left or right. So if we add that extra axis in 3D when we do inverse kinematics, the movements can get off really quickly. So you just have to kind of go slow and be careful with that. And in 2D, we don't have to worry about that problem. So let's just draw a quick character. I'll draw him kind of facing forwards. I'll start with a little head here, sort of chin, and choose some color. That'll work for skin color. Just so I can tell, looking at the face, I'm just going to draw a couple little things, like maybe a couple eyes. And I'll make that white. And paste it. And a nose shape and make it just a little bit darker than the skin. That'll probably work. Copy this. Paste that in there, and then make it just a little bit darker so it stands out. That'll work. That way we can tell we're looking at the front of a face, not a lot of details here. Your animation might do that. You might draw all the shapes, but once it's set, it's going to be set. So I'm going to select that and hit Control G just to turn all of that into one shape. Control G for group. Group and ungroup. Control Shift G turns it back into a bunch of separate shapes for editing. So it's a reversible action, but just more convenient to have that whole face as one thing. Just because of this, how I did down here, it looks like that could probably use some different colors to look like a beard. It looks all wiggly like a beard, but I'm just gonna make that a really long chin line. Draw a neck and object lower. Put the neck behind the chin. Scroll down a little, maybe zoom out so I can see sizes. Now I'll just quickly draw it. Whoops. A shirt, a torso, all of that. Not sleeves. Sleeves are going to move with the arm, right? So those are going to be separate. Let's go with the green shirt. And I'll just put them in a t-shirt. So I'll put a little sleeve over here. And another little sleeve over here. I have to ungroup it so that I can copy the color from the face. And then paste that in. Okay, now I have something else to copy from, so I'm going to group that back together as a single shape. Then our forearm, we're going to have it coming down this way, something like that. And then I'll just do a circle for a hand. And I'll grab that sleeve and under object, raise that up so that it looks like the arm's inside of the sleeve, which we have to redo that when we get over to the game engine anyway. So I guess that's not absolutely necessary here. And same thing on the other side, so I'll come down. With the upper arm. And lower arm, and then a circle for a hand. That looks very disproportionate. Let me. Scale this arm down a little bit so that it's not massively bigger than the other arm. That'll work. Then all three of those need to move to the bottom, which we'll have to do that again in the game engine, but just to kind of make sure we have the right idea. And then our body's gonna need set up differently. So I'm gonna do some hips and kind of draw them like shorts so that it's it'll overlap a little into the upper leg. Y'all might have noticed I didn't do that last night, and then when I started moving the leg, the gap was showing up between them. And then we're going to be doing 2 bone inverse kinematics, so we need to have at least 2 bones before the thing we want to move, and for like walking or kicking or other things that we want the character in the game to do, it's really the foot that we want to move, and the leg needs to come along with it. It's like the hands are what needs to move, and the arm's going to come along with it. I can see a layer issue again already. This needs to be behind the hand. Lower it again. Put it behind the thing. Or if you go to the layers tab. If you go to the layer tab, you can just drag things up and down. Might be a little bit easier. Or not even worry about that part right now because we have to do that again when we get over to the game engine. So I'm going to draw a circle for the upper legs, for the rough shape of them. Another one for the lower legs. And then I'll draw a couple shoes here at the bottom for the foot. Black shoes maybe. There we go. That'll work for our character, but just all the parts separate is the big thing. Save time on importing it. I'm just going to start a new Godot project and then save it right there in the project files. But the big thing is you want to have all those parts separate and they're still editable, right? So on the first draft, just try to go for the shape you want, the size you want. And then you can start putting your skeleton and your animation together with that, and then come back and do better edit in some better drafts on that initial shape. And as long as it's still the same shape and everything, I'll call this inverse. Create a project called inverse. As long as it's still the same shape, you just replace the original image with the improved one. It doesn't all have to be done sequentially, all in one sitting. All right, now let's save that in the right spot. So file and save this in that project that was just created. I'll just leave it drawing, that's fine. And now if we go to export it, we can export each item one at a time. So if you added some details on stuff, make sure you group them together and then hit that checkbox for selected only. So our head and our neck's going to be separate, right? If we want to move the head, we're going to do 2 bone inverse kinematics. So we need 2 bones leading up to the thing we want to move. So let's see this. Navigate to that project again. members. And this will be the head. Then right below it. Our neck. This torso. I'm going to call it right sleeve because of the way the character is facing, but because of what we just saw with turning things around, it would probably be more common to call that front sleeve, front and back, the one towards us and one away from us, instead of right and left. Because if we flip the character over, that's no longer the right sleeve. But
Well, unless you do it from the character's point of view.
Yeah.
Then it would always stay, this one's right, this one's left.
That's true. That would work. Whichever way makes sense. It just seems very, very common to call it front and back. But I think that's what makes sense in my mind is the character's point of view.
Yeah, good.
The right arm and the left arm.
Trying to do it from stage right to stage left, that would change how the stretch space.
Yes. So here's our left arm, left sleeve. Then we have the upper right arm. What's that?
Really though, I guess really it would only change if they're facing away throughout. If this is the plan, if instead of facing this way towards the audience, facing away from the audience, that would be the only time right and left would be switched.
Yeah.
If they're walking around.
Yeah, because I just called the right arm. I used the stage right. It's the left side of the screen. So upper right arm, and make sure you're giving them nice descriptive names so you can tell what's what. Lower right arm, because they're just going to come in a jumble, and we have to put them back in the right spots. And right hand. Upper left arm. That would have been just like left hand. Upper left. All the hips. Upper right leg. Upper right leg. Leg. Great, a whole bunch of pieces. But really, it's the exporting is the only extra step because we would have to draw all those pieces to draw a character anyway. So it's just the difference is how we export them. And then we can come back and do subsequent drafts and right, these are just the starting images, come back, make that look better and better and better. It doesn't have to be done in one sitting. Or right, sketch out an idea like that and then send that to the art department. Be like, here's the character I want, and let a professional artist turn your character with those exact sizes and everything into something that looks really, really good. Different ways of doing things. But now we should have all these pieces over here. So create a new 2D, a new scene, and didn't say it on the dragon. We went ahead and attached the script to the dragon when we were doing it, but really all that was graphics. So we would probably take that and put it into a physics body or a character body or something, and then the one we created would just be take the place of the sprite for the graphical body. Likewise, so we don't need the character body or anything here. This this is what's gonna take the place of a sprite with just a whole scene of nodes to work with. I'm just gonna call it character. And to start with, it's gonna be just like what we saw for the direct control bones. We'll create a container to put all of our images in. Call it parts. And then drag the images over here one at a time. So got the head, neck, the neck needs to be for the head. Torso, right sleeve, left sleeve, um, down. I'm actually just gonna drag all these in. Left arm, right arm, and same first. Oh, looks like I forgot to export the lower or the upper right leg. Maybe I didn't. It wouldn't have the name there if I didn't. Upper left leg, upper right arm. Okay, yeah, I don't see it there, so it's the right folder. Upper right leg. Save. Replace. Okay. It's behind Zoom. Oops. There was more to my screen there. It was probably showing on the one behind me. That's gonna find it. Then the lower legs, lower right leg, lower left leg, right foot. So there's all our images. Then maybe adjust this. So I'm gonna drag these around and get them all in the right spot. So like the hips, we put hips and torso right in the middle. Might be a good start. Then everything that's left can go behind it, and everything that's right can go in front of it. That make a good split. And then just make sure they're in the right order. Left, upper left arm, right arm, that's gonna come down here somewhere. Left hand's gonna be on the other side of the torso. Right hand, left leg's gonna be on the outside of the torso or the hips. Left leg goes to the other side. Left foot goes. Okay, looks like everything's in the right order there. Well, actually, the left sleeve should probably be in front of the arm. There we go. looks like I got everything in the right order. When I drug them up, they just became children of the root node instead of that container. So I'm just gonna select all of them real quick and drag it over so they're in that container, and we can collapse that and kind of save us some space. And just like we saw on Monday, our skeleton needs a special type of container. So when we add a new node, search for skeleton, and then we'll start adding bones. Go 2D. First one's going to be the hips. And I'll just drag that into kind of where the hips are going to go. This one, it will matter a little bit more where that point is at the very end, the point that those graphics revolve around. That's where things rotate from. So we really want that right at our seams, but for now, just get it close and we'll adjust it later. So now we can get all of our bones. So off the hip bone, child of a hip bone is going to be the backbone. I'm dragging up to just right below the shoulders. Remember, we need 2 bones, and then the object we want to move is what we're going to need eventually. So I need 2 bones to go through the neck. So just to keep some meaningful names, I'm going to make one and call it shoulders. It's not going to bend much at all. It's just a little bit of fluctuation there at the top of the bone. Then another bone called for the neck. And notice how each subsequent bone is a child of the previous one. So it's indented. Those will all make it one long chain all the way up to the head. I forgot to move the neck into place. Grab that. We'll put it there. Neck. And then the head can just be somewhere down this there. Maybe the next 2 columns. We'll have to come back and adjust. We'll come back and adjust them and get everything right. Just make sure we have enough bones for now. I'm gonna come back to the shoulder and make a new child of this for I'll call it right sleeve. Just an alignment bone, but really what it is so that when the upper bone comes out of that, the pivot point is at the right spot. So we want the pivot point on the next bone, the first one that's actually going to move in the arm, to be right there where the upper arm starts. And that'll be a new chain starting at the right sleeve there. Upper arm. Probably label everything clearly, and they're different types of things than our images, so we can give everything the same name as the image, just to keep it straight. And then, so put that right about the starting point, and then make a child of it for the lower arm. And just drag that to about where that arm needs to pivot from. One more there, the hand. I'll put it right there, right about where the wrist is actually. So wrist would have been a more accurate term for that than hand, but matches the picture. See what I mean about a little bit more tedious than what we did the other day? Because we just have a lot of bones. And when we start doing the assignments and movements and stuff, we'll probably have to make little modifications to their position. Now we can go back up to the shoulder and grow the left arm. So another bone for the left sleeve. And the left sleeve will be the parent of the upper arm. And that's going to be the parent of the lower, the forearm. Should have probably called it that. Lower left arm. And then that is the hand. And then we just need to move those into position. So I just did it two different ways there, right? I created the bone, moved it in position, then created the next one, or that second time, I created all the bones and then went through and moved them into position one at a time. You might find one way easier than the other. Personally, I like the latter one. You just have to make sure that you move them all at the same time. Because if I move the hand out, then as I move everything behind it, it's going to push the hand further and further out. So the upper arm, I'm going to start rotating about there. Lower left arm is going to start rotating somewhere right around here. And the hand is at the rotation point for it, so around where the wrist would be. So that's the upper body. Come all the way back to the hips, we can start doing our legs. So we'll create a bone that just kind of I'll do the upper left bone instead of the connecting one here. No, I'm gonna do a connecting one. So I'll call this like the right pelvis, sort of what that bone is, the actual hip thing, I guess. And then bring it over a little bit, which that bone's not going to do anything except make our skeleton look more like a skeleton. Right? We have connecting bones that aren't involved in the movement, which can help with organization. The child of that will be the upper right leg. And then that's going to be the parent of the lower right leg. Which is going to be the parent of the foot. And then we can move them into place. So the upper leg's going to start rotating right around here somewhere. The lower right leg's going to start rotating around the knee. And the right foot is going to start rotating from around the ankle. And back to the hips to do the other side. Where we have a left pelvis. I guess thigh would have worked as well. And I was kind of drag it out. The shoulder bones are kind of the same way. It just gives it more of a fills out the shape. And not every bone in our animation has to do something, but it helps to organize it and makes it look a little neater. Right? Like when we did the dragon, it kind of looked like a star instead of an actual dragon skeleton. Yeah, not necessary, but it can be helpful, especially as they get more complicated. What do we have? The upper left leg. Then the lower left leg. Then the left foot. So the upper left leg is going to start rotating around there. The lower one about at the knee. And the left foot will start rotating from where the ankle's at. There's all our bones. We can get rid of these warning messages. Come up to the skeleton 2D. And in the button that appears at the top center, click overwrite rest pose. So now we have a spot to get our bones back to. But now we have to do that other part. Remember, the remote transform to control all those parts. So the hips, remote transform. What I like to do is just create all of these and then come back and assign them one at a time. So on the back, hit Control A, add a remote transform as a child of the back. Now it tries to put it at the bottom. So just a good first step is to go through here and create them one at a time. Control A, put in a remote transform, and shoulders next. Then the next one, Control A, remote transform. That goes with the neck. Control A, remote transform. And when it gets to the very end of the chain, you don't have to move it, but all the other ones you probably want to move into place so that it's a little bit easier to tell what goes with what bone. Right sleeve. Well, the right sleeve's not really going to control anything. That's just one of those filler bones. The upper right arm is where we need the remote transform. So if it's not going to be moving anything, we don't need that other node on. Put that in there, and then on the hand, remote transform, and that should be in the right spot. Left sleeve is just a filler bone. Left arm, we get one. Oops. That's gonna get one. So you can see there's quite a bit on the setup, but it goes fairly quick. The pelvis was just a filler bone, so we don't need to worry about that one. The upper leg is going to move, so it's going to get a remote transform. Lower leg, get a remote transform. Obviously, you can do this in different ways, but this is what I found works really well. Just add all of these and come back and assign them afterwards. That's just a filler bone. This one's going to move. This one's going to move. This one's going to move. I think that's all of them. Yep. Now we've got to make those assignments. So the left foot, oops. We select the remote transform that goes with the left foot and assign it to the left foot, obviously. So one of the places where naming the things the same is nice. And the computer will never get them confused because they're different types of nodes. So it's okay to reuse those same names. And then we will move our bones, right? The bones are what always moves. And then this is just an internal thing that transfers the transform data about the bone to whatever object we assign it to here. A really, really useful node for 3 of your final projects involve things where something's going to follow your main character. So remote transform can be helpful for that. You just set it off, offset it a little, and then that carries all the transform data from the main character right to the other one. So where am I? Lower left leg. Assign that lower left leg. So you can see a little bit tedious, upper left leg, but not too bad. Right foot. Just make sure you put a little, put in a little forethought, right? Plan a little bit ahead of time, like naming everything the same so that it's easy to find what goes with what. Lower right leg. Upper right leg. Which hand was that? Oh, that must be the left. Which it's kind of in the wrong spot. I'm gonna go fix that real quick. So I don't come back, forget to. The lower left arm is on the wrong side of the torso. So I'll move that up here somewhere. There we go. That's another thing I found over the years. If you notice something that you got off on, it's best to fix it immediately. I guess the standard way to say it in our society is it's like telling yourself to go get gas in the morning. Right? Not the best idea. It's like, oh, I'll come back and fix that. But really easy to forget those things. Upper left arm. And which I named incorrectly. I assume that's the right hand. Lower right arm. Upper right arm. Neck. Shoulder. Yeah, actually, I don't think our shoulder needs to move. There's not anything for it to control. So I'm gonna take the remote transform off that. Then the back is the torso, and then the hips where everything started. All right, so those are all assigned. You can see things moved around a little bit. So now we need to move them back in place and move the remote transform. Let's keep the bones in the same spot. So our back has shifted the torso up, so I'm gonna bring that down kind of where it started at. The neck, oh, make sure you grab the remote transform and just offset it from the bone. As we start moving things, which we'll have to do in a little while, they're all right sleeve, upper right arm, probably good. Go to the lower right arm, forward, and the right hand is going to need to move forward a little as well. Back to where it started at.
How do you use a chest arm to move the bow?
The remote transform moves your graphics.
Yeah.
So the bone stays the same, but since the remote transform is a child of the bone, when you move the bone, right, if I move the upper left arm here, the graphics come with it. So since the parent-child relationship stays the same, so moving the bone moves the remote transform, and then that moves the graphics. Did that answer your question? So, yeah, so we want to offset the remote. Offset the remote transform to the right spot so that our graphics are starting at the right starting point. Upper right leg looks like it's in the wrong spot. Oops, I'm moving the bone. Make sure you move the transform, because the bone should be in the correct location. Lower right leg, take that down. And foot, something like that.
Moving the remote transform seems to only move the graph. Doesn't seem to move the bone anywhere.
Oh, it shouldn't move the bone. So the bone moves the remote transform, and the remote transform moves the graphics.
So you move the graphics via the transform. Okay. So you don't have to move the
Yes. Well, for this right now, where everything got shuffled around when we made those assignments, you want to move the remote transform, because your bones should be in about the right spot. But it would have got off a little bit. Whoops. And then you can do a check to make sure the right thing's there, right? So if we grab the head bone and the rotate tool, it looks like we can, just the head rotates. I'll do that. And then you can go through and do them one at a time. Upper right arm. And notice from that parent-child relationship, when we move the upper arm, the lower arm comes with it. Which,
so when you move the one bones next, the graphics that are connected to those bones that are near it also.
it should be happening. So like if I grab the upper right arm, like those, all of the ones that are in the parent trap, that are children of that.
Yeah. The bone itself. So the head head bone I have as the child of the spine upper bone. But when I move the head, it doesn't.
Oh, it only goes one way.
Oh, okay.
The child can't move the parent. Oh, that's a great analogy for that, right? Think about a little kid wanting to go down the toilet aisle at Walmart and pulling on their parent's hand. The parents can pull the child along, but the child's not going to pull the parent. Okay, I misunderstood your question. Sorry about that. Okay, give that a save, and then looks like it's a good time for a break, and then we'll do set up the inverse kinematics after a quick break, and then do the split up into breakout rooms to talk to your teammates for the group. 10 minutes sound good to everybody? Need a longer break? My clock says 2:21, so we'll get back here at 2:31. I'm gonna get a sip of coffee. Stop the recording.